We can solve question 13 by using guess and check. So this represents the area of the big square. This represents the area of the small square, while this represents the difference. And we must ensure that the difference between the big square and the small square is less than 10. So suppose the area of the big square is 4 times 4, which is 16 cm square. The area of the small square must be equal to 3 times 3, which is 9 cm square, because 16 minus 9 is 7, which is less than 10. And suppose if the area of the small square is 2 times 2, which is 4 cm square, the difference between 16 and 4 would be more than 10, which is not acceptable. And if we further increase the area of the big square to 5 times 5, which is 25 cm square, the possible area of the small square would be 4 times 4, which is 16 cm square, because the difference between 25 and 16 is less than 10. And if we further increase the area of the big square to 6 times 6, which is 36 cm square, are we able to find any possible value of small squares? Let's try 5 times 5, which is 25 cm square. The difference would be 36 minus 25, giving us 11, which is more than 10. If we try 4 times 4, which is 16 cm square, the difference would be 36 minus 16, which is 20, and is more than 10. So, the further we decrease the area of the small square, the higher we get. So, if we further decrease the area of small square, we further increase the difference. Hence, the maximum possible dimension of the big square must be 5 cm. Hence, the maximum possible perimeter is 5 times 4, or 5 plus 5 plus 5 plus 5, which would give us 20 cm.